Bismillah Rahman Rahim. Assalamu alaikum everyone. Today I will discuss chapter number 14 from your textbook. This chapter has two parts. One part deals with the risk of a capital budgeting project or projects, and the other part deals with the managerial options or real options in capital budgeting. But before moving forward, I would like you to recall the preceding chapter where we have assumed a single required return in determining which capital budgeting projects a firm should select. Further, we have assumed that the acceptance of any investment proposal would not alter the business risk complexion of the firm as perceived by the suppliers of capital. But you know that different investment projects often have different degrees of risk. The project that is expected to provide a high return may be so risky that it causes a significant increase in the perceived risk of the firm. In turn, this may cause a decrease in the firm's value. So in this chapter, we consider various ways by which management can gauge the risk of a project or a group of projects. Our ultimate objective is to come to a better understanding of how risk affects value. For that purpose, we must first be able to measure project risk under a variety of circumstances. By providing information about the expected risk of an investment proposal or proposals together with information about the expected return, management must evaluate this information and reach a decision. The decision to accept or reject an investment proposal will depend on the risk-adjusted return required by suppliers of capital. So in this chapter, we develop the information necessary to evaluate risky investments. In addition to risk, investment projects sometimes embody options for management to make decisions at a later date. Once a project is accepted, management may have flexibility to make changes that will affect subsequent cash flows or the project's life. This flexibility is called a managerial or real options. So this chapter begins with the general introduction to project risk and follows with the consideration of its specific measurement. Next, an investment project is examined with respect to its firm portfolio risk. That is the marginal risk of a project to the firm as a whole. Finally, the effect of managerial or real options on project desirability will be studied. So after giving you a brief overview of this chapter, here you can see the learning objectives. First is to define the riskiness of a capital investment project. Secondly, understand how cash flow riskiness for a particular period is measured, including the concepts of expected value, standard deviation, and coefficient of variation. Third, describe methods for assessing total project risk, including a probability approach and a simulation approach. Fourth, judge projects with respect to their contribution to total firm risk, a firm portfolio approach. Fifth, understand how the presence of managerial or real options enhances the worth of an investment project. And last, list, discuss, and value different types of managerial or real options. In this chapter, we will cover four major topics. There are subtopics too, but the four major topics are the problem of project risk, total project risk, contribution to total firm risk, firm portfolio approach, and in the last, you will study managerial options. First, we'll discuss risk of a potential project. Risk of an investment project is defined as the variability of its cash flows from those that are expected. Expected value is also known as most likely outcome or mean value. By cash flows, we mean estimated cash flows or projected cash flows or forecasted cash flows. Let's take an example of a project whose life is only 1 year. Further, we assume that there is a 40% chance that we can have a boom in our economy next year. Or there is a 40% chance that the conditions will remain normal next year. Or there is a 20% chance that we can face a recession in our economy. So under these three scenarios, the cash flows must not be the same. The cash flows must be different under the under these three state of economies. So if we find the mean value of these cash flows and then calculate the variance, if the variance of these cash flows is high, the risk of an investment project is high. And if the variance is low, then the risk of an investment project is low. Or in other words, the variability of its cash flows from its mean or the dispersion around its mean value is high. The risk of an investment project is high. And if it is low, then the risk of an investment project is low. इसका मतलब यह हुआ कि अगर जो वेरिएबिलिटी है, अगर जो कैश फ्लोज हैं, अगर ये क्लोजर है मीन के, तो फिर रिस्क कम होगा। और अगर ये क्लोजर नहीं है और ये मीन वैल्यू से दूर है, डिस्पर्शन जो है अराउंड इट्स मीन वो हाई है, तो फिर रिस्क भी जो है वो हाई होगा। इट मीन्स दैट द रिस्क ऑफ एन investment project is dependent on the variability of its cash flows from those that are expected. Further explaining the risk of a potential project, here it says that in the context of the capital budgeting projects, risk results almost entirely from the uncertainty about future cash inflows. So if we are 100% sure about the future cash inflows, it means we are certain about the future cash inflows. Then there is no risk involved with that project. But if we are not 100% sure about the future cash inflows, it means we are uncertain about the future cash inflows. Then there is some risk involved with that project. But on the other hand, the initial cash outflow is generally known. Initial cash outflow is our cost of investment. At present, it is easy to estimate how much cost we can incur on that in a project because we have the market prices in front of us. So it is not difficult to estimate the cost of investment, but it is not easy to estimate the future cash inflows. Second point is that these risks result from a variety of factors including uncertainty about future revenues, expenditures and taxes. मैंने पहले भी डिस्कस किया था कि डिफरेंट हमने एक सिचुएशन ली, सिनेरियोज लिए कि इकोनॉमिक कंडीशंस जो है वो फ्यूचर में चेंज हो सकती है। एक तो वो फैक्टर्स हैं, इसके अलावा बहुत सारे फैक्टर्स हैं। हो सकता है कि मार्केट के अंदर टेक्नोलॉजी जो है वो चेंज हो जाए, इसी तरह कोई अच्छा कंपैरेटर जो है वो आपसे बेहतर कंपैरेटर वो मार्केट में आ जाए, इस तरह मार्केट के अंदर जो कस्टमर्स हैं उनकी प्रेफरेंसेस चेंज हो जाए, तो उनसे भी आपके जो रेवेन्यूज हैं वो अफेक्ट होंगे। इस तरह गवर्नमेंट जो है वो नए टैक्स लॉज ले आती है, तो उससे भी जो है वो टैक्सेस का अगर रेट डिफरेंट हो जाता है तो उससे भी आपके नेट इनकम्स अफेक्ट होंगे। Therefore, to assess the risk of a potential project, the analyst needs to evaluate the riskiness of the cash inflow. तो उस रिस्क पोटेंशियल जो प्रोजेक्ट है उसके रिस्क को असेस करने के लिए एनालिस्ट क्या करेंगे, कैश इनफ्लोज हैं उनकी रिस्कीनेस को एवेलुएट करेंगे। और नेक्स्ट स्लाइड में हम देखेंगे हमने कैसे कैश इनफ्लोज का रिस्क जो है उसको मेजर करना है। Here you can see an illustration of total risk. Now we measure the total risk of a project using discrete probability distribution. You can see the proposal A and its annual cash flows for the first year. There are 5 different state of economies. First is the deep recession, then mild recession, normal conditions, minor boom, major boom. And here is the probability. There is a 5% chance of deep recession. There is a 25% chance of mild recession. There is a 40% chance that the conditions will remain normal. And there is a 25% chance of minor boom. And there is a 5% chance of major boom. So if there is a deep recession, then how much cash flows we will receive? So here you can see that we can receive $3,000, but it is negative. It means a loss. So if there is a deep recession and its probability is 5%, then we incur $3,000 loss. In case of mild recession and its probability is 25%, we receive $1,000 in cash flows. And if the conditions are normal, then we receive $5,000. And if there is a minor boom, then we receive $9,000. And if there is a major boom, then we receive $13,000 in cash inflows. Here you can see the probability distribution of year 1 cash flows. So on the x-axis, we have drawn cash flows, and on the y-axis, you can see it is a probability. So it's a bar chart. If you just look at this bar chart, you can see that the values are quite far from the mean value. So what it means that there is a greater dispersion because the values are quite far from its mean value, which is 5,000. So we can say that this proposal A has a high risk just by looking at the graph. Now we estimate risk of proposal A. To measure risk, we use standard deviation and coefficient of variation. But before that, first we calculate expected value of year one cash flows. And then we calculate the variance of year one cash flows. So in this slide, you can see that the CF1 are the possible outcomes minus 3,000, 1,000, 5,000, 9,000, and 13,000. And in the second column, you can see the respective probabilities. And in the third column, we multiply the cash flow 1 with probability 1. So minus 3,000 is multiplied by 0.05 and 1,000 is multiplied by 0.25. So these are the chances of occurrence of these possible outcomes. So we have multiplied these, and after adding up all these cash flows, we get expected cash flow at year one, which is equal to $5,000. Now estimate the variance of year one cash flows for proposal A. So these are the possible outcomes, and the variance is that we just subtract these cash flows at year one from the expected cash flow and take a square of that and multiply it with the respective probability. And you multiply it in the next slide, you will see the results. So here you can see that after subtracting the possible outcomes from the expected cash flows 5,000 and taking the square and multiply it with the respective probabilities and adding up all these cash flows, we receive the variance of a project. If we take the square root of this variance, you will get the standard deviation. So if you take square root of variance, you will get standard deviation. So here the standard deviation of proposal A is $3,795. But you must know that standard deviation is an absolute measure of risk. Since it's an absolute measure, it has some limitations. If we compare two proposals having the same expected cash flows or the mean values, then higher the standard deviation, higher the risk. But if the two projects differ in terms of expected cash flows, then the standard deviation does not explain which project is having a higher risk. So at this point, we need a relative measure of risk. And the relative measure of risk is coefficient of variation. Because the coefficient of variation measures the risk per unit of its mean or with respect to its mean. So when the two projects differ in terms of expected cash flows, then we use coefficient of variation as a measure of risk. So now we estimate the total risk for proposal B, and then we compare it with the proposal A. So here are the annual cash flows for year one. 5 different state of economies you can see in this table, and the relative probabilities and the estimated cash flows. If you just look at this graph, you can see that the cash flows are quite closer to the expected value or the mean value, that is $5,000. So if we compare this graph with proposal A, you can see that the variability of cash flows from the expected value is less than the variability of cash flows from the expected value for proposal A. So just by looking at this graph, we can easily say that The risk of proposal B is less than the risk of proposal A. So to support our graphical analysis, now we calculate standard deviation and coefficient of variation. But before that, we calculate expected cash flows and the variance of cash flow. The procedure is same as it is applied on the proposal B. So after applying the same procedure on proposal B, we get the standard deviation of $2,846 and the expected cash flow is $5,000. So if you can see that in this case, both proposals are providing the same expected cash flow. If the two proposals are providing the same expected cash flow, then the two methods, standard deviation and the coefficient of variation, both will give us the same result. But if the two proposals are differs in terms of the expected cash flows, then we prefer the coefficient of variation over the standard deviation because coefficient of variation is a relative measure of risk. So in this case, we can see that the standard deviation of proposal B is less as compared to the standard deviation of proposal A. So it means that this project, proposal B, is less risky as compared to the proposal. So on the basis of risk and return, here you can see that the expected cash flow for both projects are same, but proposal B is less risky as compared to proposal A. So we select proposal B because it is less risky and producing the same expected cash flows. The other method, coefficient of variation, is 56.9% relative to its mean. So here you can see that the coefficient of variation of proposal B is also less as compared to the coefficient of variation of proposal A. So both methods are providing you the same result. But if it differs in terms of expected cash flows, then you prefer the coefficient of variation. So this point you must keep in mind when you select the two proposals having the different expected cash flow.